Okay, hi guys, here is our video 1-11 and it's about the intermediate value theorem. So you are given that f is continuous on the closed interval 1 to 4 and the table of values below. Use the intermediate value theorem to explain why there exists a value r that is between 1 and 4 for which f of r equals 7. Illustrate your explanation with a sketch. So we're going to do the sketch first. And the intermediate value theorem, I will give you the formal theorem in the next lesson. Like I'll actually give you its definition. So what we're going to start out by doing is doing a sketch with this table of values. So we've got, so our x values are 1, 2, 3, and 4. So I only really need the positive side of the x-axis. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, now my highest, so my y values, I've got 5, -2, 8, and 10. My highest y value is 10. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My lowest y value is -2. So I'll go like that. And, sorry, it's a little blurry. Okay. And then from there, I'm going to plot these points. So 1, 5. So there's 1, 5. And 2, -2. So 2, -2. 3, 8. Here's 8. Here's 8. It's like there. And then 4, 10. Okay. Alrighty. Now it says use the intermediate value theorem to explain why there exists a value r between 1 and 4. Okay, so here's 1, here's 4. So we want to find a value r between, we want to explain why there has to exist a value r somewhere between here for which f of r equals 7. Okay, so y value. So we want a y value equal to 7 for some x value between 1 and 4. Okay, so let me find, all right, so here's 7. All right, so 1, 2, 3, 4, 5, 6, 7. All right, so that's like where 7 is. So I'm just going to draw a horizontal line there. Okay, guys, this will, if this is confusing, just try to keep up and this will all make sense eventually. Okay, so I'm drawing just this line there. No, it's not perfect. So that's the line y equals 7. Okay. And I want this to be f of r. Okay, now here's the thing, guys. This point here, this y value is f of 1. All right, because f of 1 is 5. 1, 2, 3, 4, 5. Yeah, f of 1 is 5. And then, so this is, so for the leftmost endpoint, this is the output. For the rightmost endpoint, 4, this is the output, 10. So this is f of 4. And now let me introduce this word intermediate. All right, I looked this up on I Googled this. So intermediate means coming between two things in time, place, or order. So coming between two things in time, place, or order. So guys, if you look here, this 7, okay, 7 right here, that is an intermediate value between f of 1 and f of 4. All right, so what we're going to say here, I'm going to start the explanation, and you'll see how it comes together. So use the intermediate value theorem to explain why there exists a value r between 1 and 4 for which this. All right, so it's always going to start like this. You're always going to say, all right, so I'm going to say f of 1, all right, which is our first, which is our, okay, so we'll just say endpoint. We'll say left endpoint, and then this is the right endpoint of this interval, or of this, of that interval also that we're given. So left endpoint, right endpoint. So you want to do f of the left endpoint and tell your reader what it is. It's 5. I'm getting that from the table. And then the right endpoint, f of 4 is 10. I'm getting that from the table, and I've got those points there. All right, so I've got f of 1 is 5, I've got f of 4 is 10, and 7, we'll say y equals 7. And y equals 7 is an intermediate value. So what you're saying here is that, you know, you've got these y values for the endpoints of the interval that we're working with, and you're telling your reader that 7, this y value that we need to explain why this y value has an x value here, we're saying that it's an intermediate value. Okay, so f of 1 is 5, f of 4 is 10, and y equals 7 is an intermediate value. Okay, now we want to explain why there needs to exist a value between 1 and 4 for which f of r equals 7. So basically, guys, we need to prove that the graph of f of x needs to have an x value between 1 and 4 that has an output that basically hits this green line. Well, guys, the way that this is, you know, I took the values that were in this table and I plotted them, all right? And then here, this green line, that's, on this green line, all of the points on this green line have a y value of 7. Well, this green line, the way that I plotted these points, this green line doesn't share any points with that were on this table. So how am I going to prove that there is a value between 1 and 4 for which f of r equals 7 hits that green line? How am I going to prove that? Well, that is where this comes in. You were given that f is a continuous function. Guys, if f is continuous, that means that we can connect the dots. So I can connect these dots just like that. And connecting these dots allows us to pinpoint right here f of r. Okay, so f of r is 7. So where is r? R would have to be like about right there. Okay, and I know that this feels like a lot right now, but it's going to come together, I promise. I'm going to, you know, I'm going to treat this super carefully. So guys, the fact that this is continuous, so two facts. Y, 7 is an intermediate value between these y values at the endpoints. And if we add on, so we have that intermediate value. If we add on the fact that f is continuous and we connect the dots, then we can say to our reader, yes, it must happen that we've got an r value between 1 and 4 for which f of r is 7. So the explanation goes like this. We already put this part, and now we're going to say since f is continuous on 1 to 4, okay, since f is continuous on 1 to 4, comma, by the IVT, which stands for the intermediate value theorem, which I will give you the formal one later, by the IVT, there must exist a value r, comma, between 1 and 4, for which R equals 7. So this is it, guys. This is the explanation. Now, for something like this, the more I talk, the more your head might spin. So what I recommend, after we're going to do another example, or actually, I really, really recommend this, guys. Pause the video, read this whole thing over, and just sit with it. Just try to digest it until it makes like more sense to you, until your brain starts to put the pieces together. And then we're gonna do the second example, but really, if you have the time, pause the video and just read this whole thing over and try to make it, make sense in your brain. Okay, let me read this. F of 1 is 5, f of 4 is 10, and y equals 7 is an intermediate value. Y is between 5 and 10, basically. Since f is continuous on 1 to 4, by the intermediate value theorem, there must exist a value r where 1 is less than r is less than 4, for which f of r equals 7. Boom. Okay. All right, now I hope you paused the video and made sure that made sense to you. Let's do another. You were given that h is continuous on -3 to 8, and the table of values below, right here. Use the intermediate value theorem to explain why there exists a value c between 1 and 2 for which h of c equals 0. Illustrate your explanation with a sketch. Okay, so I'm going to do the same thing as before. I'm going to start with the sketch. Okay, my k values are going from -3 to 8. So 1, 2, 3. So there's -3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so -3. 0's right here. 2 is there. And 8 is there. Okay, now let me do the outputs. I look at my outputs. My highest output is 6. My lowest output is -12. So I'll just scale my y-axis so I can fit those in. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So at -3, the output is 6. So that's the highest one. Oh, and by the way, So this is up here, so that y value, which is 6, is f of -3. So I'm going to show on my y-axis where f of -3 and f of 8 are, so that you could see the intermediate nature of of 0 here. So there's that. And then f of 8 is 1. Oh, shoot. Oh. I'm not even using. Oh, shoot. I want to go from 1 to 2. Oh, yeah. All right, this is great. All right, so h is continuous on this. I forgot that it goes like this. Huh. Okay, sorry, guys. If you're using pencil, we don't actually need that, because this interval that they're giving us continuity on is different than this interval here. All right, so it's really f of 1 and f of 2 that I care about, because I'm proving the value c between 1 and 2. Alrighty, so shoot. Oh my gosh. Okay, I totally messed. I should have done this earlier. Okay, I think I needed to change something. I think I needed to make this 1. Okay, let me do that. All right, so let's make this 1. Yeah, okay, so this will work. So 1, 2, 3, 4. Okay, 1, 4. All right, there. And this 1 is right, that's one of the endpoints that we're proving that we have a value on for which h of c is 0. So I'm going to highlight that here. So this is H of 1. Oh, duh, and I used F before. Sorry, I'm tired. And then we've got 2, negative 12. 1, 2, 3, 4, 5, 6, 7. That's all the way down here. Oh, wow. All right, so this is H of 2. All right, so H of 1 is up here, H of 2 is down there. And the reason that I'm labeling them is because those are the Y values at these endpoints where I'm proving I have a value on, for which H of C is 0. And then we've got 8, 1, 8, 1. Okay, now, so there's those points separately that I got from the table. And I'm proving that explaining that there exists a value of C between 1 and 2 for which H of C is 0. So I want Y equals 0. And guys, Y equals 0, that's just the X axis here. So I'm just gonna highlight it. All right, now just like before, all right, so this here, this value here, so that's Y equals 0, and like H of, all right, and like this Y value here, H of C. Alright, that's like what I did last time. Yeah, because like I put F of R where that green line was, and now I want H of C to be like where this green line is. Okay, and look at this, guys. We've got 0 between H of 1 and H of 2. So 0 is an intermediate value between the outputs of these endpoints that I'm proving there is a value on, for which H of C is 0. So I'm gonna do it the same way. I'm gonna say H of 1 equals 4. H of 2 equals negative 12, and Y equals 0 is an intermediate value. Okay, boom, that's how we started. Now, I don't see, like this table of values here does not share a point with this green line. However, we know that H is continuous on negative 3 to 8. So I can connect all of these points. So I can connect, so this gets connected to there, which gets connected, which goes almost vertical down there, and then, whoop, so it looks like that. And then right here, guys, where the graph hits here, this would be, like that would be that C value. All right, and then this is 1 right there. So we've got this value of C between 1 and 2 for which H of C equals 0. All right? Now, here is the thing. Before, we had that F is continuous on 1 to 4, and then we were proving that there was a value of R between 1 and 4, between the endpoints of that same interval. So we were able to say down here, since F is continuous on 1 to 4 by the IVT, there must be a value of R, blah, blah, blah. So here we had that the interval of continuity was the same, had the same endpoints as this interval that we were proving, the value exists on. But here, this interval is different from that. But guys, here's the thing. So this interval 1 to 2 is actually contained in this larger interval negative 3 to 8. So, look at your picture, we were able to connect all of these dots. So if H is continuous on negative 3 to 8, well then it must also be continuous on 1 to 2. So we're gonna say that this time. So blah, blah, blah. Since since h is continuous, CTS can be continuous on -3 to 8, it is also continuous on 1 to 2. And for now, guys, you're just trying to mimic me as much as you can and in class, and then I'll give you, in video 12, I'll give you the formal theorem. It is also continuous on 1 to 2. And then what did I say before? Okay, since this. And then I'll be like, therefore, those 3 dots are therefore. Therefore, by the intermediate value theorem, and then you just mimic this, there exists a value C between 1 and 2 for which this. There exists a value C, 1 is less than C is less than 2, for which h of C equals 0. Okay, let me just read it. So h of 1 is 4, h of 2 is -12, and y equals 0 is an intermediate value, meaning that 0 is between 4 and -12. Since h is continuous on -3 to 8, it is also continuous on 1 to 2. Therefore, by the intermediate value theorem, there exists a value C between 1 and 2 for which h of C is 0. Okay. And h of C equals 0. Okay, guys, I am wondering, and we could talk about this in class. I'll ask you guys. I'm wondering if it makes more sense, instead of saying y equals 0 here, to say h of C equals 0. And instead of saying y equals 7 here, to say f of r equals 7. Because in the end, that's like what we're trying to say anyway. I don't know. We'll think about it, and we'll talk about it in class and see if we want to do that instead. I'm sure both are fine, but I want to do whatever works for you. Okay, buddies, so I know that this was kind of a long video, maybe not for Calc Standards, it's not, but the video from last year was twice as long as this, so I think I did a better job this year. All right, I'll talk to you later. Bye-bye.